Good morning, everyone. My name is Adriana Romo, Office and Events Coordinator for the North and Central America region here at the EIC. I'd like to welcome you to today's live event, Quality Challenges and Risks in the Evolving Hydrogen Supply Chain. Before we get started, I would like to go through a few housekeeping items so that you know how to get the most out of today's webinar. You are listening and using your computer speaker system by default. If, however, you would prefer to join over the phone, please select the telephone in the audio preferences found in the audio panel, and the dial-in information will be displayed. Now you may notice your control panel will automatically collapse when not in use. To keep it open, just click on the View menu option and uncheck Auto Hide Control Panel. Now, due to the number of attendees we have today at the webinar, we have muted everyone but the speakers. However, we want as much interaction with you as possible, so please do submit your questions, technical support requests, and comments to us in the questions panel, and we will address this in the Q&A session. You may also notice in your control panel that there is a handout section, and today you will have a handout which can be downloaded at any point during the webinar, which contains today's speaker bios and our delegate list. Without further ado, it is my pleasure to now hand you over to our Regional Director for North and Central America, Amanda Dion. Welcome, Amanda.
Thank you so much, Adriana, and welcome to today's webinar. I am personally quite excited. I am definitely one of those who is excited about everything hydrogen. And being as we have over 160 delegates joining us today, I think everyone else is just as excited as well. You know, COP26 has been a driving force for the industry to decarbonize, and hydrogen has been at the center of that. And from reducing the emissions associated with the production of hydrogen for existing applications, utilizing hydrogen as an energy carrier for industrial feedstock, to adopting hydrogen as a low carbon technology option, it does have a significant role to play as we are now in this arena of decarbonization. So we have Leanne Halliday, Corporate Account Manager and SME for Hydrogen with LRQA, joining us today to provide us a presentation that will help to set the scene on where we are right now in looking at the challenges and risks in an evolving hydrogen supply chain. We're then going to take forward a roundtable discussion, and Leanne will be joined by Noreen Faizi, Director, Strategy and Growth for Hydrogen with Worley, as well as Catherine Zimmerman, Business Development Manager with Wood. At any point in time, please use the questions panel. If you have any questions and or comments, we definitely want to hear those. Feed those in through the questions panel, and at about 5 after the hour, I'll start going through those and organizing them and get those to the roundtable participants to address. We're going to quickly close at 10:15. And again, I'd like to thank everyone for joining us today, especially our speakers. Now, what I want to do is provide a bit of a scene setter before I hand things over to Leanne. If we could go to, yeah, thanks. So just for everyone's information, the EIC is currently tracking well over 300 hydrogen projects in EIC data stream with about 378 billion of investment globally. However, hydrogen is still representing a small share within the greater global energy capex. But the sector is growing with the second highest share of new energy investment since the beginning of 2021. And with these projects, green hydrogen is leading in terms of both number of projects as well as CapEx spend. We can go to the next slide, please. And if we look at major green hydrogen projects across the globe, there's a strong opportunity, a pipeline of opportunities in Australia and the Americas, particularly the US, Brazil, and Chile. And then we're followed by Oman, Egypt, Namibia, Argentina, and Greece. So our top developers, next slide. So CWP is a major player planning to bring online massive green hydrogen capacity by the end of the decade. And the Asian Renewable Hub is one of the world's largest integrated energy projects with an estimated capex of 36 billion US dollars. FFI, so they are taking forward an ambitious pipeline of green hydrogen projects in Australia and South America, and many other developers involved with offshore wind projects to feed power to their electrolyzers. If we could go to the next slide, please. Then, if we look at the top contractors, and we're looking at key contract awards by the company as well as the project location, there's been 111 hydrogen-related contract awards since January 2021. There are about 27 contract awards for equipment supply, and we're seeing the traditional contractors such as Thyssen, Siemens, and Baker successfully diversifying into hydrogen and are capturing orders across the globe. So that's a bit of a scene setter. And with that being said, I would like to invite Leanne to the stage.
Good afternoon, good morning, everybody.
Hi, Leanne. Thank you so much for joining us. Just to properly introduce Leanne, as I mentioned earlier, she's the corporate account manager and SME for hydrogen with LRQA and is a chartered chemical engineer with 20 years experience in the energy sector. Leanne has design, project management, and sales management experience across the UK, Asian and Australian markets, and she's worked for LRQA for over 10 years, focusing her extensive experience and expertise helping industry to assure safety and quality across the supply chain. Leanne is currently a member of the Australia Standards Hydrogen Working Group and engaged in hydrogen projects globally. And delighted to have you here today, Leanne, and thank you so much for delivering this presentation. The floor is yours.
Thank you, Amanda. And thank you, everybody, for attending the call. It's great to see so many participants. I'm usually based in Perth, Australia, but today I'm speaking to you from the UK. And yesterday I was in Rotterdam speaking at the Global Hydrogen World Summit. It was great after COVID to be part of a big event again. And really for me, again, excited me for hydrogen and gave me an opportunity to see how excited the industry is and how many people are actually involved in the industry. So our presentation today, as Amanda said, is looking at the quality challenges and risks in the evolving hydrogen supply chain. So being a global company, we speak to regulators, manufacturers, operators, financiers, a lot of people involved in hydrogen projects on a daily basis and have done for a while. Through these interactions with myself and other stakeholders, we've also been able to consolidate some of them risks. And that's what this presentation gives you today, is an idea of what we're seeing at a global perspective and how we can summarise them risks and what a company like LRQA and other people in the industry can do to meet them risks and help people to make this exciting world of hydrogen opportunities an actual reality. Next slide, please. So before I get started, I'd just like to introduce LRQA. Many of you will be familiar with Lloyd's Register. LRQA was divested from Lloyd's Register in 2021, with Lloyd's Register now focusing their efforts into the maritime industry, and LRQA looking at providing quality and risk assurance across the whole supply chain. We have a real focus towards ESG and sustainability projects moving forward, helping you to look at the risks, what you face today, tomorrow and beyond. If we look at the next slide. We do this through a series of services, whether that's third-party certification to particular codes or standards, or in fact your own codes and standards. Verification, second and third-party inspection services, making sure that across your vendors and across your supply chain, you're managing risk and quality at every step. Training, and also importantly in today's world, cybersecurity. We deliver this through a whole flexible approach by having face-to-face inspectors at a global level, blended solutions where we look at face-to-face and remote operations to take into account what's happening today, particularly in China. I've just been speaking to my colleague in China who's facing real issues with lockdowns, so we have technical solutions to be able to combat that. We go to the next slide. Just briefly touch on our experience in the renewable space. We've got many years experience over many megawatts of projects across all different types of renewables, and definitely getting involved in the hydrogen projects. Amanda mentioned a lot of the projects are in Australia. A lot of our hydrogen project experience is there. Starting to do some certification of some of the vessels, etc., that are being involved in the pilot projects. But I'll talk a little bit more about that in my future slides. Next slide. Okay, so now let's get into the presentation. Like I said at the start, this is a combination of a lot of conversations we've had with stakeholders globally, whether that's regulators, manufacturers, operators or financiers, and all of the risks seem to fall into four main categories. Those categories being technology, supply chain, regulations and standards, and overarching social license to operate. So the first thing we'll do is we'll put some context around this conversation, look at where we are as a market and look at the growth for the market. We'll then look at the challenges, and then we'll dig a little bit deeper into them challenges, and finally look at some of the solutions that we have. Next slide. This slide really gives a context to the presentation. I'm sure you've all heard about the different colours of hydrogen, and a lot of confusion is built into that as well. This is the best graphic that I've found to really look at what we mean when we're talking about hydrogen and what we mean when we talk about hydrogen in a decarbonised future. So the first slide there, the first picture is using renewable energy through an electrolyzer process. So taking water to split the water molecule to give you hydrogen and oxygen. That's green hydrogen, and that's what everybody's getting excited about. When you look at the very large projects globally, the majority of them are green hydrogen projects, and the future for regulators and companies and governments to meet their COP26 targets and their own targets is definitely green hydrogen. You also see in there, we see nuclear. Nuclear is now often referred to as some shade of purple. So purple, red or pink hydrogen as well, just to confuse everything. Hydrogen production has been around for many years though, and there's many standard processes for hydrogen production, very often used in the refining and chemical and fertilizer industry. What you see there is producing hydrogen from natural gas through the steam methane reforming process to give you grey hydrogen. Then if you use coal as a product, going through the gasification process to give you brown hydrogen. Them two aren't really exciting for a decarbonisation solution, but once you had carbon capture and storage onto them and you get blue hydrogen, that's also part of the solution and part of the transition solution as well as we move towards green hydrogen projects coming online. Particularly some of the very large oil majors of many large countries such as the Middle East, where they have big gas and oil reserves. This is definitely a solution to help them to reduce their carbon emissions, but still make use of the reserves what they've got. The final one on there, I'm not sure why you would ever use, but it's really taking electricity from the grid, using the electrolysis process to give you white or clear hydrogen. I would see this being used as a backup for green hydrogen, or using the initial startup processes when your renewable projects aren't necessarily up and running. You can take it from the grid to prove technology, etc. The interesting graph on this slide shows that actually if you produce hydrogen from coal or hydrogen from gas, the carbon intensity is actually more than if you're just producing power from coal or gas. It's only when you really add that carbon capture and storage in there and different levels of carbon capture and storage that it really makes a difference. So the key to producing blue energy is the carbon capture and storage or enhanced oil recovery projects, which are on the back of them. And they're the ones that we start to see in industry at the moment. Next slide. So why hydrogen and why now? Amanda alluded to this, but it's definitely, we see in the news all the time, we see targets being set by governments, by industry, and COP26 was a real accelerator for the hydrogen industry and the decarbonisation industry. We also see here in Europe the conflict with Russia and Ukraine really accelerating projects, particularly around Northern Europe and the UK, as security of gas supply becomes an issue. I really saw that in the conference yesterday. A lot of the large projects in Europe are really starting to get pushed forward on the back of that. So all of the projects that I talk about today, all of the concepts that I talk about, are all hydrogen being used for energy or climate change mitigation purposes. So this isn't hydrogen in its common use, it's hydrogen in a new context, in a brand new solutions. Next slide. Basically, industry has three main strategies in order to reduce carbon. The first and simplest one is optimization of operations and sustainable design. So basically reducing your emissions. And this has been happening for many years. Back in 2003, I was working on a project for ConocoPhillips here in Teesside in the UK, and we were putting a lot of infrastructure on site to reduce the emissions. A lot of manufacturers are producing machinery with reduced emissions intensity to really meet the needs of the end clients. The next stage, or strategy 2, is carbon offsetting, and that's where we really see hydrogen start to play a part. Carbon offsetting, as you know, can be as simple as planting trees. I saw yesterday on the BP sand them using a carbon paint which absorbs carbon into the paint. So there's lots of different ways for carbon offsetting, but to do carbon offsetting at a scale what we need to meet the targets, then we need to look at things differently, such as blue hydrogen. The third strategy is the expansion of a low intensity business. So this is where you get real, true green projects into your portfolio, such as green hydrogen projects, such as pure solar or pure wind projects. So you'll see I've mentioned a lot of major companies on there that I'm sure you all recognise, and a lot of them have got strategies in every one of these three areas, or some of them are focusing more on strategies 1 and 2 and not necessarily moving into strategy 3. Let's move on. This is a very interesting slide, and this really tells me what work needs to be done in the hydrogen sector, both from a supply chain perspective, from a knowledge perspective, and also from a regulation and standards perspective. So if we look at where we were in 2020, we were producing around 87 megatons of hydrogen. China is actually the largest producer of hydrogen currently, but majority of that is in the refineries and chemical sector, a little bit used in the production of iron and steel, and very minority in elsewhere in the productions. By 2030, in order to meet the targets that were set, we're looking at a 2.4 times at least amount of increase in megatons of hydrogen produced. But what's more dramatic is the change in the use of hydrogen. So you'll see there we start to see shipping, aviation, we start to see the use of hydrogen for electricity generation, blending into gas grids. So hydrogen is going to be seen by everybody. It's going to be not just something that happens in a chemical plant somewhere that you very rarely pass, but it's going to be in the gas networks coming to your homes. It's going to be potentially in the cars that you drive. We're starting to already see hydrogen fuel stations popping up all over the place. I know that in California, there's a real push towards having hydrogen fueling stations and network of hydrogen as well. If we then look even further in the future and look at 2050, we then see a 6 times increase in hydrogen usage, taking us to 528 megatons at least. And again, you'll see that the mix of hydrogen completely changes as well, with the use from chemicals from 2020 going from 53% to just 11% by 2050. This means that there's a complete shift in the places where we will see hydrogen, the supply chain of hydrogen, the regulations and standards of hydrogen that will need to be used. Next slide. So let's look at the hydrogen market. So in order to meet them targets, what are we seeing? And Amanda did introduce some really good projects, and there's a little bit more research on the next slide that I'd like to share. So we looked at the IE database, and I think the thing to look at here is the difference in the number of projects. So we look at the number of projects that were in the common domain from October 2021 to from March 2021 to October 2021. So in a 6-month period last year, you'll see a dramatic jump in just that 6 months. So what I'm looking at here is all of the projects that are announced globally in the green or blue hydrogen space that are in either concept or in construction and are in the pipeline until 2040. So there's a whole big range there, and I think that's one of the things to look at. Yes, this is a very exciting market. This is something that is got a lot of noise at the moment, but are we ready yet? Perhaps not. The big projects are being talked about. Are any of the very large projects got sanctioned? Not quite yet. So we need to take that into consideration. The other thing to look at is the size of the projects. So a lot of the projects are in the less than 10 megawatt phase. These are usually pilot projects, people looking to prove the technology, people looking to see if it can be a way that they can move from strategy 2 to strategy 3 in their decarbonisation methods, but they're not necessarily commercially viable. The next step is 10 to 1,000, and I've noticed I've got too many zeros on that slide, 10 to 1,000 megawatts. These are the ones that start to become interesting, and you'll see there's a big peak in that when we look from March 2021 to October 21. The next ones are the ones where we get really excited. The next ones are the ones that are the greater than 1,000 megawatts. These are the very large green hydrogen projects that Amanda talked about being in Australia, etc. And these are where we really start to see hydrogen making a difference into the decarbonisation future of the world. The map down below, the thing to focus on here is where them big blue dots are. And you'll see the big blue dots refer to the greater than 1,000 megawatt projects, or where clusters of them are happening. See a lot of them in Australia, in places like Chile and Brazil, in North America and in Canada, and in the Middle East, or particularly there in Saudi Arabia, and then in some of the European and China countries. The one I'd like to focus on is the one I'm most familiar with, which is Australia. Why are we seeing these very large green projects happening in Australia? And it's because of 3 things. In order to have a large project, you need the natural resources, such as sun, water and wind. You need very large land mass in order to be able to have the number of wind turbines and solar farms that you need. Requires a lot of land mass, and you need a customer. You need somebody who wants the hydrogen. Australia has all 3 of them. We have within Australia the natural resources, and we have the larger land mass. But we don't necessarily need all the hydrogen or the energy ourselves, but we had close neighbours in Japan and Korea who have set very stringent targets by 2030 and again by 2050, but they don't have the land mass and they don't necessarily have the natural resources that we are able to supply. The problem you have there is, how did you transport hydrogen from Australia over the seas to Japan and Korea? And this is where you start to introduce ammonia and methanol into the mix. I'll talk later about the chemical properties of hydrogen, and now one of the issues is it doesn't boil, it doesn't liquefy until -253 degrees C, which is almost 100 degrees less than natural gas or LNG. And therefore we have to look at, although one of the advantages of hydrogen is it's portable, we have to look at how we can transport it in a more economical way. Next slide, please. This is a bit of research we've got. We've got a tool within LRQA which allows us to look at noise on the internet. So what are people searching for? What are people uploading? What's happening? So the first thing we did, we looked at where our key strategies were within LRQA. So things that we look at is food safety, regulations, business continuity, 3D printing or additive manufacturing, etc. And the thing what shone above anything else was people looking at sustainability and ESG. So that shows that when we're looking at hydrogen, we're looking at the right space. The next thing we did was we looked a little bit deeper into the hydrogen sector and looked at where people were seeing and where people's concerns were within hydrogen. And this really was synergy with what we were seeing from the market as well. We're seeing a lot of noise in supply chain. Like I said, the technology isn't new. Supply chain of hydrogen processes associated with hydrogen isn't new. But what is new is at a scale that we're seeing today. and also at a relative cost point that we need to meet to be able to have these large projects be economical. So supply chain risks are a reality. The other thing that we're seeing is electrolyzers. A lot of people are moving, although electrolyzer technology isn't new either, a lot of people are moving from oil and gas sectors, power sectors into hydrogen that don't necessarily have the experience. So the subject matter expertise, the supply chain around electrolyzers is also new and something that is a concern. We then also see issues around regulations because there is no standard regulations, and I'll talk about that later on, and gas infrastructure and pipelines. So if I go on to the next slide. So let's now look at the challenges. I've mentioned them in brief through the presentation so far, but let's look at them in a little bit more detail. So really we can look at the challenges in three main buckets. Technology and supply chain we can group as one, regulations and standards, and social license to operate. So let's look at technology and supply chain first. And this is very interesting. I mentioned technology isn't new, but the scale at which we're needing to buy, the cost point at which we're needing to buy is new. The innovations that needing to happen within technology providers to be able to produce at a scale and also at a cost point to meet the industry needs is also new. The supply chain is also different as well. I've got some real examples for electrolyzers here that I'll give you now. I was working with a company in Australia who had bought an electrolyzer from China. This was a very experienced electrolyzer provider who produced electrolyzers for the Chinese market for many years. However, it had never exported an electrolyzer. They employed us very early on to do a gap analysis of the design to make sure that the design met the Australian standards. That project never got the go-ahead because we were never able to extract the design documentation in English. Therefore, we could never do we could do the review in Chinese, but we couldn't do the review to meet the needs of the Australian regulator. Therefore, the project was pulled and they're looking for an electrolyzer and another electrolyzer provider. Another one is the electrolyzer supply chain is going to be under threat or constrained, and industry is seeing that. I've got a project that I'm working with in a very early stage, and they're not looking at taking FID for another 3 years, but they've already placed the order for the electrolyzer, preliminary order, with a company in Europe because they know that they're going to have to book their slot. The final example is I'm working with a company in India who've never produced or manufactured electrolyzers previously, but they see a need in a market in India and also globally, and looking to see how they can set up their own manufacturing in India. We're also seeing a shift in skills. We're seeing people move to this industry that haven't necessarily worked in the industry before. We're seeing people buying from a supply chain that they've never bought from before. Therefore, there's a whole need to build a trust in a constrained supply chain. When we look at regulations and standards, and I've got some more examples of this later, there are regulations and standards available for hydrogen globally. They're all very much country specific. And particularly with the largest producer of hydrogen is China, there is a lot of standards in China. What we don't have is we have very few global regulations or global standards. When you start to trade hydrogen, and the whole point, like I mentioned, the Australian example, where we'll be trading hydrogen with Asia, you need some sort of common regulations in order to be able to allow that to run smoothly. When you're looking at a constrained supply chain and therefore you have to look further afield for your suppliers, you need some common standards. There are ISO standards around, there are also IEC standards around, but they don't cover the whole value chain of the hydrogen production. Also, I mentioned in my slide that we're seeing the use of hydrogen different. Where in oil and gas we'd maybe have 1 or 2 uses. Here we're seeing a whole wider range of uses. So we're seeing it being used for transportation, for energy, for conversion into ammonia. Therefore, the regulations need to take all of that into consideration. What we need to make sure, and this is what we're working very hard on with Standards Australia, is making sure that we don't add unnecessary complexity into the standards as well. The final but probably most important area where I see the risks lying into is social license to operate. Social license to operate is making sure that when you do a project, your reputation as a company remains strong, but also the company, the general public and everybody who's affected by the project has complete trust and faith that you're doing the right thing, and what they're being given is safe and is of the right quality that they would expect. I said earlier on that hydrogen will be seen by everybody. Everybody's mamas and papas will be exposed to hydrogen if we see the industry kick off like we're expecting it to. We will see gas blending. There's a town being built in the UK at the moment where they're looking at 100% hydrogen into a network. We're also seeing fueling stations pop up for cars. I remember when I first got involved in hydrogen, I was talking to my father-in-law and he couldn't believe that we were looking at hydrogen at this scale, because he had perceptions from past disasters, such as thinking about hydrogen bombs and the Heidelberg disaster. So we need to make sure that risk is dealt with correctly. We understand the risk, we treat the risks as they should be, we build quality and safety into all of these projects, and most important, we communicate with the general public to make sure that the perceptions of risk is dealt with. I've got an example there. I moved to Australia from the UK to work on the coal seam gas sector, and that's one area where social license to operate wasn't well managed. There's still projects that I worked on in 2010 that haven't got FID and still haven't moved on from feed stage, purely because of environmental pushback, etc. If we don't get all of these risks right, what does it do? It causes delay, it causes risks for costs, it causes risks to reputation, etc. And without spending time upfront to deal with all these risks, then these projects won't go ahead. And all of these exciting projects and exciting numbers that we've talked about at the start of that presentation won't be able to be realised. Next slide. So let's look a little bit deeper into some of these examples of where we see the risks. So hydrogen is the simplest molecule. It's the first molecule on the periodic table. It is simple and therefore it's predictable, but has to be treated with respect. If I look at the chemical properties of hydrogen, chemical and physical properties of hydrogen, compared to natural gas and gasoline, we can pick out some areas which have real advantages, but also some areas that we need to take into consideration when we're looking at safety. The first one is that hydrogen actually has no colour when it burns in daylight. Therefore, from a firefighting perspective, when you're dealing with local fire stations, when you're putting together safety cases, it's something that needs to be taken into consideration. Do they need specialist equipment? Is specialist cameras required when attending a hydrogen fire? The next one is when you look at dispersion. So if we look at the buoyancy of hydrogen compared to air, you'll see that it's actually 14 times lighter than air, which is a great advantage. That means if you get a leak, it quickly releases, and therefore the risk of having an explosive environment is less. However, that does have to be treated with respect. It does have to be run through the right dispersion modellings. The dispersion modellings has to be done with people who understand hydrogen. An example is, for example, if you've got a pipeline under some gravel, if you have a leak from that pipe, then it will disperse quickly amongst the gravel, giving you a very large potential explosive area. One of the advantages is hydrogen is very compressible. Therefore, we can look at the design of pressure vessels. We can look at reducing costs with pressure vessels, the materials we use for pressure vessels, etc., to take advantage of this compressibility. But we also have to take into consideration what I mentioned previously, the boiling point, which is minus 250 degrees C. So when you're transporting hydrogen, you need to make sure that you look at this, the energy costs associated with this, the carbon associated with the power to get it down to minus 153, but also the safety and mechanical aspects, looking at the materials at this very low temperature, and also the OH&S examples. Good example I've got here is looking at loading arms from jetties. When you're loading LNG, you don't usually have any insulation on the loading arms. That's because there's so many bends and twists that it doesn't make sense to have that from a design perspective. You do get some ice buildup, but it's not necessarily that intense. If you're putting hydrogen through a loading arm, the boil off what you'll get just wouldn't make sense. You'd get immense amount of ice buildup, and therefore they're looking at putting some innovation into the design of loading arms to see where they can insulate and looking at insulation around joints. What I would say, if we do look at the chemistry as well, is being in a very small molecule, it's also a leaky little blighter. And what do I mean by that? Next slide. I mean that from a mechanical perspective, it's also very easy to get into cracks and get into damaged welding, etc. And it's something that needs to be considered when designing or selecting your material for design. If we look at the different damage mechanisms for hydrogen, I've listed there just some of them, but the one that I'd like to focus on is hydrogen-induced cracking or hydrogen embrittlement. This is something that needs to be taken into consideration whenever you're designing or looking at reusing any equipment or pipelines, etc., for use of hydrogen. What do we mean by this? So if you've got a slight crack in a material, or you've got some damage of the material, or the bonding of the material isn't quite to specification, then a hydrogen can get into these gaps and quickly form together to increase the size of the gap and have an issue. You also have to take into consideration when you're looking at welding. The welding has to be of a high quality. The testing that you do on the welding has to be increased to make sure that there's no risk of hydrogen penetrating the welding and again expanding and causing issues. Hydrogen is so small as well. You also have the risk of absorption of hydrogen into certain materials, and that's something to take in consideration again when designing and selecting of materials. Next slide. I've got an example here of how that is played out in standards. So if we look at the existing ASME standards for pipelines, and we look at BS 31.12 versus BS 31.3, which is the difference between using the material for a hydrogen process or a natural gas process. You'll see that what I talked about on the slide before regarding hydrogen embrittlement is taken into account with the way that the standard dictates what you need to do from a way of testing and stress analysis. For example, when you're doing stress analysis, you need to consider more cycles to make sure that you have taken into account the risk of embrittlement. Also, certain alloys cannot be used for the risk of absorption, etc. And you have to take into more stringent and more substantial testing methods, whether that's additional RT and UT, NDT or preheating, and also the requirements for welding qualifications and welding procedures are also enhanced and something that needs to be taken into consideration. Next slide. If we look at the general testing that you would do for a steel pipe, and you look at the difference hydrogen effect has on these different testings, you'll see that you see a significant reduction in elongation when you're using hydrogen rather than natural gas, so the durability is less. You also see it being more susceptible to fracture, and the fracture growth rate is a lot more. So that's why in the ASME standard you have to do more cycles in the design review, and also when we look at the welding, we have to make sure that there's no potential cracks, etc., for hydrogen to penetrate. Next slide. Now looking at standards, I just quickly want to run through this, and this is just to give you an idea of the standards that are out there. What I will say is the standards and regulation market for hydrogen is very dynamic at the moment. If I did a slide today, it would be out of date tomorrow, but this is just to give you a bit of an overview with what's happening. So you'll see on there the Chinese standards, there's much more of them than any other standard. We are seeing ISO standards and IEC standards either being updated or rolled out on a monthly basis, if not more regularly, and they're covering a whole range of different things. For the US, we do see a whole range of hydrogen standards particularly be coming in. We've mentioned ASME ones as well, but we're also seeing some NFPA ones coming into use, and there's a whole lot of US standards being developed. You look there at the mix of standards and where we're seeing them. So at the moment, majority of standards are in testing and in safety. We're seeing less standards currently in production and applications. I think as we move forward and we really see a shift in hydrogen being used for fuel, etc., that we'll see much more standards in the applications and fuel quality space. Next slide, I've got an example from an Australian perspective. So what we're trying to do in Australia, like I said, is not add complexity, and also realise that from a trading perspective, there has to be some commonality across global regulations. So our first point of call is to look at ISO and IEC and see if they can be adapted or adopted for an AS purpose. So currently we've looked at around 14 and we've adopted around 14 hydrogen standards, particularly for the hydrogen market. Next slide. But we're not even nearly there. So even if I look at what we've got to do, there's still 70 plus regulations that need to be reviewed, 10 plus pipeline standards, 30 plus fuel cell standards, etc., etc. So there's a lot of work that needs to be done. So the idea is to look at prioritisation. What's of immediate relevance? What do we need to make the Australian projects a reality? What has a safety aspect? What is going to help or hinder our social licence to operate? And therefore putting the effort in them first to make sure that we roll out in the right time frame. One of the things that we're doing from a national strategy here in Australia as well is also putting some case studies out there. So it's also all well and good having all of these standards and regulations, but when a company comes to doing a project, they need some sort of case studies, some sort of models and matrix so that they can see exactly which applies, and that's what we're helping industry to do as well. It's interesting the IEC have rolled out electrolyser standards. So IEC generally focus on electrical. Electrolyser has a whole range of different things associated with. So it's not just an electrical component, it's a mechanical component, it has process safety elements, etc. Therefore, we need to make sure that all of these standards cover everything that could possibly go wrong with an electrolyser and not just focus on a single thing. There's several projects happening global at the moment. D&V are running a GIP where they're looking at gaps within these standards to see if there's anything else that industry needs to give to make sure that we cover the whole potential risks. Next slide. This slide really summarises everything what I've been saying about the supply chain. And these three bubbles and they all accumulate into the biggest risk, which is a lack of trust. It's a lack of trust from the buyers. It's a lack of trust from the manufacturers. It's a lack of trust from it being a constrained market, but also a new market. There's new equipment being involved. It's not new from electrolyzers aren't new, fuel cells aren't new, but the innovation that's been put into these, the innovation that's been put into all of the equipment is new. It's a new vendor base. The vendor base is dramatically increasing all the time. People buying from the supply chain haven't dealt with these vendors previously. And vendors are popping up in all new locations, but also projects are in new locations. Hydrogen projects won't necessarily be built in the industrial areas where oil and gas projects have been built. So we're starting to see a shift in locations as well. The rapid growth will lead to shortage, and in any constrained market, you do have quality issues. We're also seeing new people entering the market, and therefore competency and experience is something that needs to be managed. What we recommend is that you spend time up front. You don't put large inspection plans at the back end, but you spend your time and money up front to make sure that you're buying and building trust at the front end. Do vendor assessments. Send third parties or send yourselves in there to make sure that people are able to supply you with the equipment when you want it, the right quality you want it. People are using the right type of resources. People aren't using slave labour. People have the right processes in place. And then doing gap analysis. That example I gave of the electrolyser in China, spending that little bit of money up front, making sure that they could supply to the regulations and standards that you required is money well spent. We're also seeing a lot of people coming to us for regulatory advice and support. We're looking at what is best practice, and if they don't necessarily have a standard or regulation in their particular country, how can they adopt what's already out there? Next slide, please. A very quick case study that I've got, and I really like this case study because it looks at the advantages of the chemical and process properties and how a company really used them to build a pressure vessel that was reduced in cost and therefore helped to make the large projects a reality by reducing the cost point of the projects. But it's also where that really looks at one of the risks. there was no standard way to produce, to send this to market. There was no standard certification route. And therefore, although there was a lot of innovation, a great product, there was no way that this company had a direct route to market. So what they did, it was a consortium of German companies. They looked at hydrogen, they looked at using its compressibility, and looked at using glass reinforced plastic to produce a vessel that would meet the chemical properties, the physical properties of hydrogen, and also allow them to have weight and price advantages. However, when they looked at how they were going to export this, there was not necessarily any standards that allowed them to do it. So they approached us. We looked at our deep technical knowledge of all of the different standards, and we were able to certify this vessel to PED and ASME, and they're now exporting this vessel globally. Next slide. So we've looked at the risks, we've looked at the market needs, we've looked at what industry is telling us, and we want to be part of the solution. We want to help this industry become a reality. And therefore, yesterday at the Global Hydrogen Summit, we launched 4 products. And these pro projects I just wanted to quickly introduce to you guys today. So the first one is approval in principle. This is allowing manufacturers to really build the trust to the buyers, and buyers to build the trust in the supply chain. What we're finding is a lot of manufacturers have got products that they've either innovated or they are confident can be used in the hydrogen sector. However, what they don't have is any case studies for hydrogen or any experience list in hydrogen. Therefore, they're finding it difficult to get that first sale or to get them initial sales and build the trust with the buyers. Our approval in principle approach looks at the equipment, the process, or the product at a high level. We look at what risks what risks are built into the design. We looked at their high-level concept design, and we look at what standards and what regulations they've chose. On the back of that, we can issue an independent third-party certificate which says that that product, that piece of equipment, or that process is approved in principle to be used within the hydrogen market. The next step to that, once they have a buyer, so once they have some set process conditions, they have the right location, climatic conditions, etc., we can then move that to a type approval or approval in use certificate if required. The next product is certificate of origin. One thing I've talked about is having no common regulations or standards globally. For these large green hydrogen projects, they're only going to become commercially viable if you're going to get some advantage from your customers. So your customer could be buying from you because it's greener than your competition. Your customer could be buying from you to get some carbon credits, etc. This product allows us to look at the origin of the hydrogen, look at the emissions, look at the supply chain, and certify that as a green product. This has been built around greenhouse gas verification ISO standards. Although they don't necessarily apply to hydrogen, we've used the same concept so that we are having a global review. And I'm sure without very much longer, there will be some ISO standards for certificate of origin of hydrogen. And therefore, if you get certified by LRQA, you're already a step along the way for ISO certification, which is the same sort of process that we've seen in additive manufacturing and BIM as well. The next one is net zero manufacturing assurance. What we realise that it's not going to be all major companies with very large hydrogen departments building hydrogen infrastructure. It's going to be some small companies, local councils, local governments, schools, steel plants who don't necessarily have the full competency. We've produced a modular solution where we can look at all of your safety and quality risks across the supply chain and help take all that risk from you. So when you're putting some infrastructure at site, you've got the social license to operate, you're able to sell and be able to assure your communities that you have considered all of the safety and quality risks. And also you are assured that from a quality perspective, you've got the piece of equipment that you want and that will last. The final one is hydrogen standards training. Again, looking at it from a global approach, looking at best practice, informing you what is best practice, and then working with you to see what you want to adopt for your particular project if there isn't necessarily a standard route to market or necessarily a standard route for your project. Next slide. So that's it from me. I see some questions popping through on the chat, and I know that we've got our roundtable now. If anybody's got any questions after this presentation as well, I'm more than happy for you to reach out to me, and you will see some more marketing information about them products in the next couple of weeks.
Thank you so much, Leanne. A lot covered there, from the kaleidoscope of colors of hydrogen, optimizing operations, sustainable design, expansion of low carbon intensity business, how companies are looking at bringing on hydrogen to decarbonizing industries and sectors. I totally agree. People are looking at ESG, and when it comes to hydrogen, there's a lot of noise happening, and you mentioned that in your presentation. And you know, I know that I posed the question in the abstract: do we have a supply chain that's ready and capable? And there's quite a few interesting points that you put there. So at this point in time, I'd like to go ahead and start with the roundtable discussion. So I'd like to invite Noreen Fazee to the stage. She's Director of Strategy and Growth for Hydrogen with Worley. She's a strategist and business leader with over 13 years of experience in the energy industry. And she currently is exploring opportunities for genuine transformation within the hydrogen marketplace. Prior to her current role, she led strategy development for the upstream and midstream oil and gas sector in Worley. And she has an MS in chemical engineering from the University of Toledo, Ohio. And she's been recognized as the Engineering and Construction Contracting Association's Future Leader as part of CC Future Leader Program back in 2018. And then last year, she was selected as the Transition Economist Top 100 Women in the Energy Transition. So congratulations to you, Noreen. And we're also joined by Katie Zimmerman, who's the Business Development Manager for Energy Transition in the Americas with Wood. She joined Wood in 2016 as an intern and has a BS in Mechanical Engineering from the University of Texas at Austin. Prior to moving into business development, Katie spent 10 years in various engineering and project management roles, working in the offshore oil and gas shell sectors. So welcome, ladies. I must add that speaking of ESG, look, this is an all-female panel, yay. So I know that we have a couple of questions that have come in. I will remind delegates, please use the questions panel to send over any questions and comments that you may have for our panelists. So, Leanne, very detailed presentation. Thank you for that. What I'd like to ask Catherine and Noreen to talk about is, how are each of your organizations, where are you in this whole energy transition journey? Katie, can we start with you?
Sure, happy to. Thanks for having me today. I'm excited to be, yes, on a panel, not often on a panel with all women, so that's exciting. Really, right now, what we're doing is we're saying that this is unlocking the world's most critical problems. It's what we do all the time. So using our oil and gas knowledge that we have from before and pivoting to see how do we meet our clients where they are trying to decarbonize. And we're really focusing on the emissions with that. So kind of keeping UN Sustainable Development Goal 7 in mind for clean, affordable energy all around. So whether that's doing what we've always done with mitigating flaring, improving efficiencies on compressors so they're not shutting down and starting up, which uses a ton of fuel gas, looking at what we can electrify, which we've done from before, and then also decarbonizing our own fired equipment. When I first moved into energy transition, I said, okay, I'm going to ask you what's a dumb question, where are all the emissions coming from? And because I'm from upstream, and a lot of the emissions, like if you look at a map of Houston, Leanne focused on Australia, I'll focus on Houston. A lot of the emissions are, from refining. And if we look at chemical plants, refineries, where do those come from? It's a lot of fired equipment. Hydrogen units are another big offender. And then delayed coker units. There are a lot of pieces of fired equipment. And we at Wood, we've been providing fired equipment for forever. So we have our own technologies that we're working to decarbonize by improving the efficiencies, integrating carbon capture for our own hydrogen technology. That's really key for us. And then going back and figuring out where does it make sense to do brownfield modifications versus greenfield, and seeing master planning, all of this development that Leanne said we need to do. We've been doing this in oil and gas for forever. So how do you really scale, and how do you make, like for Houston, bigger and better carbon capture to realize the dream of, I call it H2 town. And so looking at what do we know as oil and gas people? I mean, like Wood, we've been making hydrogen units since the 60s. It's not new, but it's how do you make lower carbon energy for all? So that's where we are in a nutshell.
I always love it when you mention H2. Okay, and Noreen, can you comment on the question? Where are you guys in your energy transition journey?
Sure. First of all, thanks for having me on this panel, Amanda, and great presentation, Leanne. Like Katie, it is also not very often that I am on panels, so this is definitely very exciting, and specifically talking about hydrogen, which is quite an interesting topic to me, is just fantastic. So first of all, for those who don't know, Worley is a global provider of professional project and asset services in the energy, chemicals, and resources sector. And in terms of our energy transition journey, the key message that I want to give is, that our strategy is aligned with the investment trends that are happening for the shift to net zero. So we might not exactly know how the energy landscape will look in like 10, 20, 100 years from now, but we do know that it is very critical to, completing the transition to a sustainable energy mix. So, renewable fuels and electrification, circular economy, green hydrogen. There's a lot of things that we are currently working on within our sustainability portfolio. So from a business perspective, it is a very critical component of our corporate strategy. We are accelerating growth in all the new areas, and we aspire to achieve at least 75% of our revenue from the sustainability related businesses within 5 years. So Worley, like Wood, I mean, we are predominantly have been an oil and gas company, but then, that's the pivot that we are taking is, where majority of our revenue is going to be coming from the sustainability services. And finally, as our customers continue to shift from fossil fuel based energy to a low carbon energy base, we believe that we are well positioned to take advantage of those strong relationships and the trust that we've built over the years. And we have over 3,000 project experiences across a variety of markets such as solar, wind, hydrogen, energy transition materials, carbon capture, distributed energy, etc. And our purpose is simple, and that is to deliver a more sustainable world.
And of course, neither of your organizations can do that without the proper qualified supply chain. So, and this is something that Leanne presented in her presentation. It'd be good to hear from the both of you about if you agree with the challenges which Leanne has provided, or do you foresee additional challenges, or do you have any questions for Leanne around the hydrogen market supply chain? Who wants to go first?
I can.
Katie.
Me too. So one thing that I focus on, again, I'm going to focus on the Americas. What we're seeing is the need to scale. And with that, we have a lot of supply chain, but there's not enough for the scale that we've had. And with all the ups and downs of oil and gas, and with everyone waiting in energy transition for money to actually be spent, we're seeing kind of a difficult time with ramping up. And then even when we talk about the supply chain, even on who we see as like the purchasers is different, because you have the people that have been the players for forever in hydrogen, for the past and the present. They want to remain the producers of cleaner hydrogen for the future. But then you also have new players entering the market where they're not, like Leanne said, they're not used to this landscape, but they want to get that first mover advantage. And another trend that I'll say I've seen is, you know, we over time have really made our businesses more international to take advantage of cost structures in different locations. But now we're seeing more need for localization and local content. And a lot of times that local content isn't there because we've pivoted over time. So you'll have people where, yeah, they've done hydrogen projects, but they haven't done them in like 20 years or something like that, depending on where you are. And so now, like, Department of Energy funding is going to come out for hydrogen hubs. And one thing we're noticing with funding opportunity announcements from the Department of Energy now is that the local content requirement has gone from 90% to closer to 100%. So you have to file for exemptions, and they're looking for that on your design and your manufacturing. So on how do we do this? How do we scale? That's really going to be our challenge. Is you're going to get this international pool of talent, but then you're also going to have your local pool of talent as well. So a lot of how we're going to be able to scale is also going to be how do you deploy and how do you bring people up that learning curve as quickly as possible. And then standards. We could talk for a long time about standards and kind of the gaps. So really making sure that you know how you're counting everything, how you're defining everything, because when you start seeing like the SECs coming out with GHG guidance, and then you have all of these different groups starting to say, hey, somebody needs to have a metric for us all to use. We're all going to have to figure out what metrics are out there, which metric is the best metric for everyone to use, and then figure out, like, when we talk colors of hydrogen, I don't like to say colors because no one agrees on how do you count it. So we all say, like, focus on the emissions, decrease your emissions. And so as a supply chain, how do we define our emissions? What makes it green? What makes it clean? That's really what we're focusing on, trying to understand from our supply chain, what they're defining everything based on, and then how we can control what we say our impact is as we bring projects forward.
Thank you, Katie. Noreen, you want to comment?
Yeah, sure. You know, I mean, Leanne has mentioned about building trust in order to, you know, to go to the scale that we need to. And there was only one comment that came to my mind is all these offshore oil and gas facilities that we are building now, they're so mature now, the costs have declined tremendously. But then if you look back in time, 30, 40 years ago, those were also pilot projects, and perhaps that was a very complex project. And we've probably experienced the same sort of supply chain issues with those industries that are very mature today, but not previously. So I guess, you know, hydrogen being at that nascent in industry, it will require time to be able to build that. And the good part is that, you know, everybody recognizes the climate change problem, and everybody wants to contribute towards, you know, building a global hydrogen economy. And there was just one question for Leanne, if I may. How do you see, Leanne, the risk associated with, you know, not being able to supply, you know, secure long-term offtake agreements in the overall supply chain, because there's a lot of uncertainty associated in, you know, what the future costs and pricings are going to be, and therefore there's probably a little, you know, obstacles and barriers in that sense where people are not ready to accept that risk.
Yeah, and if I look at the delays in the projects of the people that I'm speaking to across the Middle East, across Australia, that's exactly the biggest challenge that they're looking at. And we look at what is causing them challenges, and one of them is regulation. One of them is standards. So until you can understand the regulations of your customer, and like Katie said, how do they define what's green? How do they define what's going to be carbonisation? So until some of that global regulations come in, I don't think we're going to see the extent of the projects that we're hoping to see. They're going to be much more localised projects rather than the very large international projects with the big off-takers. Yeah. So it all goes back to them 3 buckets of risks that we spoke about at that. Yeah.
Yeah.
Well, speaking of colors, our first question is from Alexander Sims with Alvarez and Marshall. And he's saying that turquoise was not mentioned. Is there a view that with 800 terawatts of gas being used in 2019 that we need to remove solid carbon as at source rather than dealing with CO2? Can anyone answer that?
I can have a comment. I mean, there's obviously not, one size fits all approach over the globe, right? I mean, there has to be a variety of solutions to produce hydrogen at the quantities that we are looking for to meet the net zero goals. And therefore, I think it all boils down to the maturity of the technology and the commercial viability of the project in the region that you're looking to build that particular project. So it's not like the world is only moving towards green hydrogen or only blue hydrogen, but then there's a variety of solutions that we all need to be working towards with the common goal of producing hydrogen at a massive scale, and to also enable global hydrogen trade within different regions. Yeah.
Yeah, I think that's a really good answer. And I mean, hydrogen isn't the only solution for decarbonisation either, right? We've got lots of solutions. This is just what the topic of the hour, I guess. This is what everyone's excited about, but there's lots of other solutions as well that's out there. I'm getting involved in a lot of waste to energy plants currently, but they're much more like local solutions. So we're seeing a lot of things happening.
I'll just say yes. I mean, in general, I see clients trying to play to their strengths, and we look at a lot of assessments around the dollar per ton of CO2 abated, and that really can drive a lot of your decisions. And it goes back to what is clean, what is green. So some clients are looking at just, what can I do with my existing asset with minimal OPEX to decarbonize, and they can make huge advances. And then others, because they have newer facilities that are already more efficient, they have to do something more drastic, like look at hydrogen blending, looking at, like, we do tons of renewables assessments in my group as well. And for some people, behind the meter makes a lot of great sense in markets like Texas. And then you're gonna have places where carbon capture seems like your best option for decarbonization. It really just, you have to, I hate to say it's case by case, but it really is. And I'm an engineer, so I like to say, I'm not going to pick a winner. And I think we really, as an industry, need to be sure that we don't try to pick a winner before we've done the assessments. And even if you did, the winner would be different depending on where you are, the time, like with anything. So just being flexible and keeping the energy mix.
So it seems like it's location, location, location when we're talking about the projects. And so I can't help but ask the question, when it comes to standards, will it be local standards, or because you are working with an international supply chain, will you take forward both local and international standards?
I think inevitably it'd be both.
Okay.
But I'm a big advocate for reduction in local standards and increase in international standards. And especially, like we've spoke about, one of the risks with off-takers, with the first question that we got from Noreen, is we need to have common standards. We need to be able to trade locally. We look at the risk of the supply chain. You're going to have to buy from different people. Therefore, you need to make sure that we've got somebody producing a vessel in China can export it globally, etc. So inevitably there will be local complications. Australia, we're going to have our AS 3000, which those who don't know, it's a very complex electrical standard that nobody else in the world really understands. So there will be local connotations everywhere, but the more we can reduce them complexities, and we've seen issues in them complexities with the oil and gas sector, if we learn lessons from them and take a much more global approach, that's where we're going to have the biggest impact.
Okay, Keith Robinson with Stork, a floor company. Not sure why it's so focused on electrolysis. Last week, Fluor and Stork kicked off our hydrogen project in California for an 11 ton a day mobility grade H2 production using waste to hydrogen. Offtake agreements have been signed with 2 major hydrogen companies for 100 hydrogen fueling stations to be built in California in the next 2 years. The second project is grid and land selected, feedstock agreed, and 10-year offtake agreements signed. Over 30 other projects using the same design build. Many are in various stages of development, including multiple ports around the globe. So that's a comment. Well done, Leanne. A question asking if we're going to share the slides. I'll definitely share mine. Are you happy to share yours, Leanne?
I'm more comfortable. Yeah, I've had a comment. Well, yeah.
All right, Nick Atkins, Joe Bird and Company. Superb presentation, thank you. Can markets be added to hydrogen so you can see or smell a leak? Markers, sorry, so you can see or smell a leak as we have with natural gas.
Absolutely. And I'm involved in the project with the Institute of Physics in the UK, where they're looking at what is the best smell to put into hydrogen. Yeah. In fact, the front runner at the moment is a smell that they put into the grid in Germany, because you've got to look at obviously the chemical properties and how they interact with the smell, etc. So there's a lot of research there, and it's something in Australia we're looking at as well, is which is the best smell to use or the best combination. Yeah.
What about storage? Willie Lund with Carbon 280 light hydrogen storage says there was no mention in the H2 cycle of storage. Where is this going? Can anyone comment on the storage aspect?
Storage is a big aspect, because one of the key advantages of hydrogen is its mobility. So people ask, why would you not just use solar straight to the energy rather than putting hydrogen in the mix? And one of the main reasons is you can store hydrogen a lot better than you can store electricity or solar, etc. And you don't have the complexities in the grid. So one of the things that we are looking at is storage in containers. And how do we mobilize the hydrogen around, rather than just having tank containers, which we currently use for gas, or what do we need separately for the large scale hydrogen? We're also looking, I'm involved in a project where they're looking at hydrogen storage in old salt cavities and old gas cavities. So there's lots of different projects in storage and lots of different ways you can use it, but I would say that's one of its advantages. I mentioned in my slide one of the properties is it's very compressible as well. Therefore, you're able to reduce the size of your vessels, taking into account the safety aspects of that, to have cost reductions and storage location restrictions, I guess.
Noreen, Katie, you have any comments on the storage aspect?
Yeah, I think I'm good. Yeah, Leanne mentioned.
Okay, I'm going to move on then. Ivars Crummins with McDermott International has a question for Leanne. For your case study, what was the volume and pressure of the plastic hydrogen storage vessel?
I shall certainly come back to you with that. We've got a more detailed case study that I can send. So if you send me your details on LinkedIn or via Amanda, then I can send you more details.
All right, yeah. This is a question for all panelists. Would you all agree hydrogen technology has surpassed state and government regulations? Would you agree or disagree? Leanne?
I would probably disagree. I don't think it's surpassed because it's no new technology. I guess the difference is the scale that we're looking at it. So yeah, I wouldn't say that we're outside of regulations or standards. It's just the complexity of the standards or which ones you choose for a particular jurisdiction.
Okay. Jack Riseborough with Amaranth, what is the best route of approach for established equipment designers and manufacturers who already have suitable products for use within renewable applications such as hydrogen generation to be involved in projects from the early phases where we can add great value as a solutions provider? Any words of wisdom, Katie, Noreen, in the first instance?
I would say talk to the people you think are going to have the projects and let them know. Really, right now, more with hydrogen than a lot of other things. My personal opinion is you want to be in there before an RFP comes out, because if the RFP hits, then you're probably too late. So that would be my advice, is network and make sure people know where you are and that that is a capability, and also have your little elevator pitch. That sounds like, well, of course, Katie, but having that, this is what we do and this is how it's relevant and this is how we are going to meet you where you are and help you be successful. That's really what people want to hear, because I think a lot of us can say we have relevant experience, but if somebody says, I have an absolutely massive, let's pick on green hydrogen project, who in the world can say that they have built an absolutely massive green hydrogen project at scale? No one. So it's, how are you going to be uniquely positioned to help?
And I'll just do my sales pitch here. So the product that I launched, the approval in principle, that could definitely help you. So helping to show market that your design is suitable for a hydrogen context as well could support you to get some penetration.
And the window of opportunity is very, very small, right? So you cannot just wait for the announcements to happen and figure out which contractor is working on which project. So absolutely be more proactive, and collaboration is absolutely key as we build trust across the different stakeholders within the value chain.
Yep.
Okay, Charles Ludovico with Technip Energies. He's asking, can we please pick the international system measuring standard for hydrogen for all countries? It would be great not to use gallons of H2 at XI.
PSI.
Okay.
Yeah.
PSI.
Okay.
Yeah.
Phil Millett, Honeywell Control Systems. Turquoise is methane pyrolysis. I can't say it. Only to my knowledge, BASF is researching. Okay, we have still a lot of questions and comments coming in, but we've run out of time. I'm very sorry. What we're going to do is, if you sent any comments across, we'll share those with the panelists. If you sent any questions, we'll share those and get those answered and get them back to you, or put you directly in touch to carry forward the discussion, as long as we have approval to do so. I'm sorry, I know we went over time. I think this is a very relevant topic for right now, and I think we could probably spend another hour and 15 minutes, if not longer, talking about it. But trust is everything, and relationship building needs to be done to get that trust together. So why not follow up with each other post-event? So if you would like to be introduced to anyone from the delegate list, please reach out to the EIC, and we'll work under GDPR to get those introductions taken forward. Leanne and LRQA, thank you so much for hosting with the EIC this event today. Leanne, your presentation was absolutely outstanding, very thorough, and a lot of information needed for the supply chain. And Katie and Noreen, thank you so much for coming and joining the conversation. And hopefully we can do this again really soon.
Absolutely. It was lovely to be here, and thanks everybody for your questions, and thank you, Amanda, for hosting us today.
Thanks.
All right, thank you.
Thank you.
Have a lovely day.
Take
Thank
care.
you.
Bye.
You too.
Bye.